Okay, welcome back to the third lecture of force and laws of motion, right? So in last class we discussed about the conservation of momentum, right? We derived the equation for conservation of momentum, which was m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2, right? So this was the law of conservation of momentum that we derived and we discussed. Now coming to a particular case for the law of conservation of momentum, in which like NCERT has really emphasized on this topic, firing of a gun, right? So in this particular topic, again, we have a gun and a bullet, which will again be the system, right? So we have bullet, we have gun, which is again taken as a system. Okay, so again there will be no external force, because now gun and the bullet are the system, so the force acting on the gun and the bullet will become the part of the internal force, right? So if they are the part of the internal force, then what will happen? The net external force will 0. If the next external force is 0, then the law of conservation of momentum is again applicable. Okay, so what happens when we fire a gun, right? So this is the mass of the bullet m1, mass of the gun m2. Okay, so when we will fire it, obviously initially the bullet was at rest and the gun was also at rest. So if I write about the initial momentum, it will be m1 u1 plus m2 u2. Getting my point? But because velocity for both of them is 0, so the initial momentum of the system is zero. Right? When I am saying initial momentum of the system is 0, system comprises of gun and the bullet. Okay, this is what you have to remember, that this is one system. Okay, next. Finally, after firing a bullet, the velocity will be v1 and v2 respectively. Okay, v1 and v2 respectively. Then what will happen? According to the conservation of momentum, total final momentum of the system needs to be equal to the total initial momentum of the system, right? So we'll write down m1 v1 plus m2 v2 is equal to m1 u1 plus m2 u2. Okay, this is what we have learned already. But as I told you, the initial momentum is 0. Why it is 0? Because initial velocity of the bullet, initial velocity of the gun, both of them are 0. So this gives me an idea that okay, m1 v1 plus m2 v2 is 0. Then I can also write like this: m1 v1 is equal to minus m2 v2. Now we are getting a minus sign here. If we are getting a minus sign here, that means minus sign represents the direction. Minus sign represents the direction. Okay, that means if suppose, obviously if we fire the bullet, bullet will go ahead, right? So if rightward velocity is taken positive, then the velocity of the gun will be towards left. This is what this minus sign signifies here. You're getting my point? If the bullet will go towards right and we have taken it positive, then this minus sign simply shows that the gun will go towards left. Or we can simply say that if gun is applying the force on the bullet, right? Bullet is applying force on the gun, right? So the action force of the gun on the bullet is towards right, and the reaction force on the bullet, reaction force of the bullet on the gun is towards left. This is what you need to learn. I'm again repeating myself. Suppose there is a force on bullet, force on bullet from gun towards right. So this is how I'm trying to signify the force with the arrow. Obviously it's a vector quantity, and we know that we can, write the forces in the vector form. Okay. So again, in very simple words, the force applied by the gun on the bullet is towards right, and we call it as action force. This is action force. Okay. And according to Newton's third law, for every action there is an equal and opposite reaction, right? So for every action, if there is equal and opposite reaction, so if F1 is the force acting towards right, then similar kind of force, and this F1 force is also acting from gun to the bullet. So this F1 is acting on the bullet, right? And this F2, which has the same magnitude but opposite direction, will act towards left, and this force will be acting on the gun. So if I fire the bullet will go forward, but the gun will come backward. That is the recoil of the gun. Okay. I tell you, like in COVID times, there was a game which became very famous called PUBG. Most of you have heard it. Nowadays, COD, right? So in that time, that was kind of miserable time. We were packed in our homes, right? And most of the time we were, spending time with the families, or on call with friends, and this is what we used to do. So even when it was happening in 2020, 5 years back, so I had my college friends, and they told me that, okay, Japneet, you download the game called PUBG and we'll play. So I was we can say a newbie, right? I didn't knew, I am a GTA Vice City kind of a person, or San Andreas kind of a person, but this was new to me. So one day he told me that you don't take this gun, you take the other one because it has more recoil. Okay, I tell you the name of the gun as well. That was AK-47, and he told me to take M416, not AK-47, because the recoil was much more of AK-47. So what exactly is recoil? Basically, when you fire the bullet, you get a jerk back, and this is how we test gun, that how much recoil or how much jerk we are getting on the shoulder, right? So the velocity with which the gun moves back is the recoil velocity. So if anybody asks you what is the recoil velocity, and if you want to check whether this gun is good or not, then you can check for the recoil velocity in simple words. If the gun has more recoil velocity, then obviously you need to change the gun. If gun has less recoil velocity, that means it is more stable. You getting my point? So here comes the question for recoil velocity. Okay. Recoil velocity. So what is recoil velocity? It is the velocity with which the gun moves backward. Because bullet is going forward. Anyways, you are firing a bullet, it will go forward only. So what is recoil velocity? The velocity with which the gun moves backward, right? So now why there is a change in the velocity? Because there is a force acting on the gun because of the bullet, right? Because again, according to the Newton's third law of motion, every action has an equal and opposite reaction. Getting my point? So if action force is towards the bullet, then the reaction force is towards the gun. So I told you about the recoil velocity, okay. I told you about the action-reaction pair, and also told you that here the net external force is 0 because we have taken gun and the bullet as a system. Getting my point? Okay. So let's check. So the bullet was fired, M2 V2 is equal to minus M1 V1, right? So this is what exactly happens when we fire a bullet. Okay, V2 is, if this is V2, then it is minus mv1 by m2. V2 is positive, that means velocity of gun is taken negative because of the direction. Then this is the most important thing. Here minus sign, it is not signifying anything that okay we have minus velocity. Minus velocity means it is taken in the opposite direction. Remember, this is what we discussed in first chapter. Okay, so again there are like so many questions in the NCERT related to this formula that they always ask you the either the velocity of the bullet or the recoil velocity, or they ask you about the recoil velocity. Okay, so what is recoil velocity or what is velocity of bullet? You can simply solve by this formula, and this is basically not the formula, this is the general derivation. Okay, so you can remember this general derivation that initially both bullet and gun was not moving, obviously. Then finally when the shot was fired, bullet went forward and the gun went backward. Okay, got my point? The backward motion of the gun is called recoil. This is what we have already discussed. Okay, now we have discussed about the inertia, we have discussed about the Newton's first law, we have discussed about the Galileo experiment, we have discussed about the Newton's second law, we have derived the Newton's second law, we have discussed about like Newton's third law, we have discussed about the different cases, and finally we have discussed about the conservation of momentum. In conservation of momentum, I told you a very important derivation, right? And also a particular case in which NCERT emphasizes quite a lot. All these topics are over. These two chapters only, motion and force and laws of motion, are coming in the first term. So technically your syllabus is over. But as we have to do certain practice, so I'll give you more questions on this so that you can practice, right? So this is the last phase of the chapter. You can go with the motion and force and laws of motion, you can revise, and you can let me know in the comment if you have any doubt. Okay, but for now the syllabus is over and we'll just discuss the numericals, which are very important. Not much numerical that you can practice from the reference books or the sheet we'll be sending, but let's discuss some of the numericals related to the topic that we have learnt. Okay, right. So first question says that a constant force of an object of mass 5 kg. So mass is 5 kg, duration is 2 seconds. It increases the object velocity from 3 meter per second to 7 meter per second. Find the magnitude of the applied force. So basically what you have to do is, you have to use the basic formula that you learned, which says F is equal to ma. Okay, but here we are not provided with the acceleration. So the first idea is to get the acceleration, then only you will be able to find out. But acceleration can also be written as v minus u by t. Okay, v minus u by t. What is v here? 7 meter per second. What is u here? 3 meter per second. So F is equal to, mass is 5 kg, 5 into 7 minus 3 by 2. So force is coming out to be 5, 7 minus 3 is 4, 4 divided by 2 is 2, so force is coming out to be 10 Newton. So he applied the force of 10 Newton, because of which its velocity got changed from 3 meter per second to 7 meter per second. Okay, got my point? Right. So finally you got the answer, we got the acceleration, and then we finally got the force acting on the object is 10 Newton. Okay, got my point? Coming to the next question. which would require a greater force accelerating a 2 kg mass at 5 meter per second or 4 kg mass at 2 meter per second. So you can easily check here by just applying the formula. You can find out the net force. So in the first case, let's take case 1 and then let's take case 2. So in case 1, we have 2 kg mass whose acceleration is 5 meter per second square. So force is ma. Here also force is ma, right? But because different masses, so here force is 2 into 5 and here force is 4 into 2. So here force required is 10 Newton and here force required is 8 Newton, right? So obviously 2 kg mass with an acceleration of 5 meter per second square will require more force. Let's understand this. This is what we do basically, but let's understand from the, this animation. So there is a boy who's applying a force on 2 kg block and this is moving with an acceleration of 5 meter per second square. Now there is another block and another boy who is exerting a force on a 4 kg block and the acceleration here is 2 meter per second square. Okay, so this is 2 kg block, this is 4 kg block. So eventually you'll be able to understand that when we compare it, A and B, we compare both the masses, we compare both the acceleration and eventually we got the force, right? So force F1, F2 or F2 is greater than, now we can simply check. F1 is M1A1, that is 2 into 5. F2 is M2A2, which is 2 into 4. So it's very basic that you will get 8 Newton. So F1 is greater than F2. This is what we have already discussed. Got my point? Now, coming to the next part. 2 persons managed to push a motor car of mass 1200 kg at a uniform velocity along a level road. So we have a level road on which they are pushing the car that is moving with a uniform velocity. The same motor car can be pushed by 3 persons. So initially when it was moving with a uniform velocity, you need to tell me, was there any acceleration on the level road? If 2 people are applying some force, there must be some acceleration, no? But in the first case, it is clearly mentioned that at a uniform velocity, okay? With what force does each person push the motor car? Now we have to consider, assume that all the person push the motor car with the same muscular effort. So muscular effort is basically the muscular force. Okay. Now it's very easy to understand. How? Let me tell you. Mass of the car is given. It is 1200 kg. Okay, mass of the car is given 1200 kg and the acceleration is 0.2 meter per second. So force came out to be 1200 into 0.2. Force is basically 240 Newton. Just check. Now, if this force was applied by 3 different people, you can simply divide it by 3 and you will get the answer. See, mass is, to find force, F is equal to ma, then 240 Newton force exerted by each person, because obviously it is same, so it is 240 by 3, that is 80 Newton. Got my point? So the final answer, which is 80 Newton. Okay, clear? Coming to the next part. A truck starts from rest and roll down a hill with a constant acceleration. Okay, it is rolling down. Basically, not rolling means it is coming down. Okay, and it started from rest. Here the acceleration is constant, that means velocity is continuously increasing. And we have a distance that it traveled 400 meter in 20 seconds. So what we can do is, we can find out the acceleration first. Now how do we find out the acceleration? Also find its acceleration and also find the force acting on it if mass is 7 tons. Okay, the mass is given 7 tons and you have to find out the acceleration. distance is given 400 meter, time is given 20 seconds. So just simply use this formula, S is equal to ut plus half at square. Now if S is equal to ut plus half at square, initial velocity was 0, right? It is simply telling that a truck starts from rest. So if it is starting from rest, initial velocity will be 0. So this is 400 is equal to half into acceleration, we don't know. Time 20 seconds. So 20 square is 400. Okay. So what we got the acceleration is 2 meter per second square. So we have the acceleration 2 meter per second square. Now simply force is 7 tons into the acceleration. You can change the tons, right, into 2 meter per second square. This is the answer. Let's just check. So initial velocity was 0. It rolled down the hill. Distance was 400 meter. Time is 20 seconds. We have to find out the acceleration, right? So initial velocity was 0. Distance traveled was 400 meter. Time was 20 seconds. Mass of the truck was 7 tons, which was obviously can be written as 7,000 kg, right? Okay. So we have already done this. You need to find out the acceleration. You need to find out the force. So we use this formula, S is equal to ut plus half at square, and second formula, F is equal to ma. So here we got the acceleration 2 meter per second square, right? Because initial velocity was again 0. Okay. So we got the acceleration 2 meter per second square. Then force, simply 7,000 into 2. 14,000 Newton. This is the final answer. Truck moves with an acceleration of 2 meter per second square and the force acting is 14,000 Newton. Okay, got my point? Now, the next question, again, now this is very important question because, you know, it is acting for a very short interval of time, that is 0.01 second. Okay. Initial velocity of the nail was 0. Mass of the hammer is 500 grams. Moving at 50 meter per second. Strikes a nail. What is the force? See, now this is what you need to remember, that when, remember this, that when this hammer will strike this nail, it will eventually stop. Okay. So if I am striking the hammer like this, so it will stop. Initial velocity was 50, mass was 500 gram and time was 0.01 second. So initially it stopped. I mean initially it was moving and finally when I hit the nail, it stopped. So I can simply find out the retardation in the hammer and I can multiply it with the mass of the hammer. Then I'll get the reaction force on the hammer, which is eventually the action force on the nail, and it is asking what is the force of the nail on the hammer. Okay, they are only asking for the reaction force, right? You getting my point? You need to change the reference frame in this. Normally we were looking for nail, but this time we are looking for the hammer, right? Hammer mass is given 500 gram, initial velocity is 50 meter per second, right? And the nail stops hammer in a very short interval of time, that is 0.01 second. So what you can use is F is equal to ma, or in the place of a you can write v minus u by t. Okay, now we have the final velocity 0, u is obviously given minus 50, right? U is given 50. So 500 divided by 1000, because it is 500 gram, we need it in kg, because here it is meter per second. Okay, got my point? So 0 minus 50 by time, 0.01 second. Okay, this is the, here you will get the negative force. Why you will get the negative force? Because the final velocity is becoming 0 and initial velocity was 50 meter per second. That means this nail, if it is receiving the action force by hammer, then here you are getting the reaction force, and because of the reaction force this hammer is stopping. Okay, got my point? Just check force, you have to find it out. So we have already converted 500 by 1000. Initial velocity 50, time is 0.01 second, final velocity is 0 meter per second. Okay. To find out the force, we have the formula A is equal to V minus U by T, F is equal to ma. Now we already used this. We first find out the acceleration, which we have eventually done. Right. So A is equal to minus 50 by 001, or we can write acceleration is minus 5000 meter per second square. This negative sign shows that finally the body is stopping or it is retarding, right? Negative acceleration is basically known as retardation, okay, or deceleration. Getting my point? Now simply use F is equal to ma, multiply it with the mass, and you will eventually get the force, minus 25,000 Newton. Got my point? Is it clear till here? Okay. Coming to next question. So we have a stone whose mass is 1 kg with a velocity of 20 meter per second across the frozen surface of a lake and comes to rest after traveling a distance of 50 meter. So initial velocity of the stone was 20 meter per second. Like there is a boy who is throwing the stone across the frozen lake, right? And eventually it comes to at rest. Okay. Now the distance traveled before coming to rest is 50 meter. Then we have to find out the force of friction. Okay, friction is acting because consider the stone and the frozen lake as a rough surface. Okay, so obviously this stone will get retarded, right? Because it is coming in contact with the frozen lake, right? Or the ice. Clear? So initial velocity is given 20 meter per second. Distance is given 50 meter. Okay. Mass of the stone is 1 kg. Eventually, its final velocity is 0 because it is come to at rest. Okay. Now, listen to me. So, force is equal to mass into acceleration, and force of friction is the opposing force, right? So it will eventually come to the negative. Okay. So F is equal to m V minus U by T. Okay. Right. So we need the acceleration first. This time is not given, right? So we need the time so that we can find out, or we can find out the acceleration directly. Okay, because if I use this equation, v square is equal to u square plus 2as, then final velocity is 0. So u square is equal to minus 2as. So from here I can directly get out the acceleration here. So u is again 400, u was 20, so u square is 400 equal to minus 2 into acceleration into 50. Because distance travelled by the stone before coming to rest was 50 meter. Okay. So acceleration here is minus 4 meter per second square. Acceleration is minus 4 meter per second square. Okay. Now force of friction, mass is 1 kg. So 1 into minus 4, it will be minus 4 Newton. So force of friction between the surface and the stone is minus 4 Newton. Let's just check the calculation here. Okay. So final velocity was 0, distance traveled was 50 meter, force is equal to ma, v square is equal to u square plus 2as. This is what we used, right? So finally you got the acceleration minus 4 meter per second square. Negative sign, obviously it shows that retardation is happening, and I already told you that force of friction will obviously, it will be negative force, right? Because it is retarding. Clear? So 1 into minus 4, so minus 4 Newton is the force of friction, because of which the stone is stopping. And the negative sign shows obviously the direction in which force is acting in the opposite direction of the motion. Okay? Is that clear? Now coming to the next question. This is the question from the NCERT. Okay. So let's discuss it. So we have 8000 kg engine which pulls the 5 wagons. These are the 5 wagons which are connected, and each of them is 2000 kg. So this is 8000 and each one of them is 2000. Okay. So we have 5 wagons. The total mass of the train and the wagon is 18,000, because 5 into 2000, that is 10,000, plus 8,000, so 18,000. Okay. If the engine exerts the force of 4,000 Newton and the track offers a friction, okay, so if train is going towards right, friction is acting towards left. Okay, so train is going towards right, friction is acting towards left, then the net accelerating force we need to find out. Okay, so we have the formula F net is equal to ma, like we usually write down in a simple way that F is equal to ma, but the reality is it is F net is equal to ma. Why I am writing F net here? Because train is exerting a force of 40,000 Newton, but it is also experiencing the opposite force, that is force of friction, that is 5,000. So the net force here came out to be 35,000. Okay, and the total mass, if you talk about the total mass is how much? 5,000. The 5,000 is the mass of this, 8,000 is the mass of the engine, and 5 wagons have total mass of 10,000, so total mass is 18,000. So acceleration came down to be 35,000 divided by 18,000. Okay, so it is 35 by 18. This is the acceleration caused by the engine on the wagon or complete. The force of wagon 1 on wagon 2, let's just check this out first and then we'll discuss the next part. Okay, so mass of engine, mass of each wagon is 2000, friction force is 5,000 Newton, force exerted by the engine is 40,000 Newton. So net accelerating force is, right, it will be force exerted by the engine minus force exerted by the tracks, because force exerted by the tracks are in the opposite direction, that is force of friction. Okay, so it is 40,000 minus 5,000, that is 35,000 Newton. Okay, so if we find out the acceleration here, F by m, simply 35 by 18,000, so it will be 1.94, or I have just broken down into 35 by 18 only, so it's the same thing, 1.94 meter per second square, right? So now in the next part it is also saying that force of wagon 1 on wagon 2, right? So force of wagon 1 on wagon 2, this is very important. So what will be the force on wagon 1? Right, force of wagon 1 on wagon 2. So it will be the mass of 4 wagons behind the wagon 1. Let's just check if I go ahead with this into the acceleration, right? This is the force, because we have 5 wagons here. Take a look. Right? So this force on wagon 1 will be due to this 4 wagons, right? 4 wagons has a mass of 8,000 kg, because each one of them is 2,000. Acceleration we know 35 by 18 or 1.94, right? Okay. So we have 8,000 into 35 by 18. So simply we can write it down. See, the wagon 1 is experiencing the force due to 4 other wagons, right? So it is simply 8,000 into 1.94, and you will get the net force on the wagon 1 due to the wagon 2. 2, 3, 4, 5, because there are like 4 wagons connected to the first one, right? So all the 4 wagon, because on second wagon it will be due to 3, 4, 5. On fifth wagon it will be due to itself, right? So on fourth wagon it is due to fifth. On third wagon it is due to fourth and fifth. On second wagon it will be third, fourth, fifth, right? And on first wagon it will be second, third, fourth and fifth. Okay. Now coming to the next question, there is an automobile vehicle whose mass is 1500 kg. What must be the force between the vehicle and the road if vehicle has to be stopped with the negative acceleration of 1.7 meter per second square? So the question here is that the mass is given for an automobile, okay, and this has to stop, okay. That means the final velocity will eventually come out to be 0, okay. But I just need a simple force because we are directly provided with the mass and acceleration. So this should be the force of friction if I need to stop this. That is 1500 is the mass into 1.7. Okay, getting my point, right? So if I have to stop this, I have to apply some force. I'll eventually apply some brakes, and then final velocity has to become 0. Initial velocity is not given because we are directly provided with the acceleration, right? So mass of automobile is given 1500 kg, acceleration is given minus 1.7 meter per second square. So force of friction, what will be the force of friction? Same way, F net is equal to MA, F is equal to M, like M will be 1500 into 1.7. So this is the force of friction minus 2550 Newton. This is the force which the brakes will apply on the tires to stop the car, okay, right? Or eventually it is being stopped by the road, then eventually this is the final force, that the force of friction between the car and the road is being applied, okay. But the value will remain same, 2550 Newton. Because the car was moving in the right direction, this force is acting in the left direction, okay. That is why we are giving minus sign. So minus sign always signifies the direction. Is that clear? Okay. Coming down to the next question. A force of 5 Newton gives a mass m1 and acceleration. So there is some mass, but if I apply 5 Newton force on that mass, I get the acceleration 10 meter per second square, okay. And mass m2 and acceleration of 20 meter per second square. What acceleration it would give if both the masses were tied together? Okay, so eventually what you have to do here is, first let's solve for m1 and m2, okay. Once we know the value of m1 and m2, same amount of force will act on m1 and m2 together, okay. Then we can find out the acceleration. So simply use F is equal to m1a a1 and F is equal to m2a2. Why I am using this? Because force acting on both the masses are same eventually, right? F is equal to m1a1 and F is equal to m2a2, right? So force of 5 Newton, 5 is equal to m1 into 10. So m1 is 5 by 10, that is 0.5 kilogram, okay. If I solve for m2 the same way, 5 by 20, so it will be 0.25 kilogram. If I join m1 plus m2, so it will be 0.75 kilogram, right? m1 plus m2 will be 0.75, okay. Now same force, so F is equal to m1 plus m2 times A, okay. So force is 5 Newton, it is 0.75 into A, or A can be 5 upon 0.75, which is eventually 500 by 75, and this you can eventually solve. That is, okay, let me just solve it for you, 20 by 3. So acceleration will be 20 by 3 meter per second square. Got it? Okay. Let's just see. So acceleration is 10 meter per second square, force is 5 Newton, total acceleration m1 a1. Then we found out the first mass, right? 1 by 2 or 0.5 kg. This is what we have already done. For the second one we did like 0.25 kg, total mass is 0.75. Then we applied and eventually we got the answer, that is 5 upon 0.75. 20 by 3 is anyways 6.67 meter per second square. Okay, got my point? So you got the acceleration that if the two blocks move together, the acceleration will be 6.67 meter per second square. Okay, coming down to the next question. It says the velocity time graph of a ball. Okay, let me get the velocity time graph. Okay, this is the velocity time graph, and we know that the slope of the velocity time graph will give you acceleration. But here you can clearly see that it is a negative slope, right? It has the negative slope. If it has negative slope, that means we'll get the negative acceleration. Negative acceleration means the retardation, right? This is what we can, not even without reading the question, we can simply see that okay, velocity time graph is given, slope of velocity time graph will give you acceleration, and if the mass is given, then you can directly find out the force, right? Yes or no? Also, I told you in the first chapter that area under velocity time graph will give you displacement. Okay, so this is what you have to remember. These questions, even in any references book or any good book also, these are like till this level only. Okay, these questions are till this level only, and these are enough for you to get the understanding of the chapters. Okay, so need not to worry that what the graph is doing here in the second chapter, because graph was in the first chapter. Eventually physics is interrelated, right? So because I need to get the acceleration, how can I get the acceleration? If I have the velocity and time, or if I have the velocity time graph. So with the graph, the slope of the velocity time graph will give you acceleration, right? And the area covered under the velocity time graph will give you the displacement. So that's an easy thing if you remember what is being taught in the first chapter. So even if till now you haven't seen the videos of the first chapter, you can go through it. Okay. So now let's again read the question. The velocity time graph of a ball of 20 gram moving along a straight line is given in the figure. How much force does the table exert on the ball to bring it to the rest? So you have the acceleration. Eventually here in 10 seconds, right, initial, this is, just take a look. Initial velocity was 20 meter per second, okay? 20 centimeter per second. At time t is equal to 0. This took 10 seconds for the final velocity to become 0, okay? It took 10 seconds. So initial velocity was 20 centimeter per second. Now you can also, even if you don't understand the graph, you can solve numerically. Let me do it for you. U is 20 centimeter per second. V is 0 centimeter per second, right? Time taken is 10 seconds, right? So simple. Now what you can do, you can find out the acceleration. Acceleration is V minus U by T, yes or no? And V is what? 0 minus 20 by 10. So eventually you got minus 2 centimeter per second square. The acceleration. So force came out to be mass into acceleration. So 20 gram into minus 2. So it is minus 40 gram centimeter per second square. Okay. Or 40 dyne, you can simply say. Also, if you need to find out the slope, just take a look. 20 by 10 minus 20 by 10. So it is again minus 2. Slope is minus 2. Acceleration is again minus 2. Right? So with the slope, it would have been, it's the same thing, but the mathematical, formulation would have become little bit easier if we talk about. So you can solve this question in like two different ways. One is by just writing down the slope of the velocity time graph, or you can simply check the values and you can just write it down and you can use the formula. Okay, but I would really recommend to do this like with this method, because this is typically good, you know, because in class 11th when you will go to the senior classes, this will help you a lot more when it comes to the you know, little bit complicated question. If the question is easy, then yes, it's fine, you can do it with, you know, mathematical formulation. That is the other thing. But I would definitely recommend that you should solve these questions with the graph. Okay, are we clear with this? So coming to the next question, so again 0.02 kg, they have converted, I have like written the answer in dyne, and in the PPT that is in the Newton. So it's the same thing, either you can solve in the Newton or you can solve in the dyne, it's the same thing. Typically the answer will be the same, only the difference will be that, you know, here because we are getting the value, so they are getting very small value, rather than I would prefer that solve in dyne, it's the same thing. Okay, because both the values were given in CGS, you know, centimeter, gram, second. So eventually it's same. Okay, coming down to the next question. A motor car is moving with a velocity of 108 km per hour, okay, and it takes 4 seconds to stop after the brakes are applied. Okay, so it took 4 seconds, which is eventually the brakes are working completely fine. The force exerted by the brakes on the motor car with its mass along with the passenger is 1000 kg. So what do we have here is initial velocity was 108 km per hour. Okay, so let's first of all convert this 108 km per hour into meter per second. So what we can do is 108 into 5 by 18, right? So when I'll solve this, let's simplify it. So this will be 54 and this will be 9. Then 9 1 6 and 6 5s are 30. So eventually the car is traveling with a speed of 30 meter per second. Okay, the car is traveling with a speed of 30 meter per second. Now initial velocity came out to be 30 meter per second. Final velocity came out to be 0. Okay, because the motor car has to stop, so the final velocity will become 0. Then how much time it took? 4 seconds. So time was 4 seconds. Now simply use the formula F is equal to ma. Okay, mass is how much? It is 1000 kg along with the passengers, so 1000 into acceleration, we can find it out. It is v minus u by t. So 0 minus 30 by 4. 0 minus 30 by 4 is minus 7.5. So minus 7.5. So force applied by the brake is minus 7500 Newton. Okay, is it clear? Minus 7500 Newton, the force was applied by the brakes. Okay, coming down to the next question. Just check. 108 was converted 30 meter per second, final velocity was 0, time was 4 seconds, mass was 1000 kg, acceleration is v minus u by t, F is equal to ma. This is what we have done, right? 30 by 4 is 7.5. So force eventually is minus 7500 Newton. Minus, again it is showing that if the car is moving towards left, the force is towards right. If the car is moving towards right, force is towards left. So basically this is the retarding force that we are talking about. Okay, retarding force. Got my point? Okay, next question. A bullet of mass 10 gram traveling horizontally with a velocity of 150 meter per second strikes a stationary wooden block. So it was traveling with 150 meter per second and it strikes a wooden block, comes to at rest, so final velocity becomes 0 and the time taken is 0.03 seconds. So time interval is very small. So we had a maximum retardation in a very short interval of time. Calculate the distance of penetration of bullet into the block. Also calculate the magnitude of force exerted. So we need to find out, like suppose, first of all, if I shot the bullet and it was traveling with 150 meter per second, okay? In front of it I kept a wooden block, right? Now, it stopped eventually and it stopped in 0.03 seconds. So we have to find out the distance, okay? Now we can use two formula here. One is S is equal to ut plus half at square. So S is equal to ut plus half at square, and from here I can find out the acceleration, right? Or what we can do, if I don't have the value for acceleration, what I can do is first I can find out the value of acceleration, that is v minus u by t is equal to a, right? Once I know the value for acceleration, I can put it here and I can find out the distance traveled. Also, if I know the value of acceleration, then I can simply write down the force, okay? And this acceleration will definitely come in negative because again it is retardation. Whenever, you need to remember this, whenever final velocity is less than the initial velocity, remember this basic thing. Whenever the final velocity is less than the initial velocity, that means it is retarding. Whenever final velocity is greater than the initial velocity, that means it is accelerating, right? So this is a very basic thing to understand, and obviously using this equation of motion we can simply solve, okay? So first of all I'll find out the acceleration and then I'll find out the displacement, and also I can find out the force, okay? So let's solve this, right? So I have the velocity 150 meter per second, time is 0.03 seconds, so just write it down. U is 150, time is 0.03, right? Velocity is eventually 0. So V minus U by T. Let's use this. V minus U by T. Acceleration came out to be V minus U by T. Final velocity is again 0. So acceleration is minus U by T. So minus U is how much? Minus 150. So acceleration minus 150 divided by 0.03. So you will get 5000 here. Acceleration, or we can say negative acceleration, is so large, that is why it stopped so early. That means there is a large amount of force exerted by the block on the bullet, okay? So 3 ones are 5s are, you will get 50, you will remove 2 decimal places, so acceleration is minus 5000 meter per second square, right? Or you can simply say that there is a retardation of 5000, either way, okay? So retardation of 5000 meter per second square. Now once we have the acceleration, we can solve for displacement. Displacement is S is equal to ut. Now remember, this had this initial velocity, okay, right? Or I would suggest that rather use this formula. It would require less, parameters. V square is equal to U square plus 2S. So V square will eventually become 0. So U square is minus 2as, right? Acceleration is also negative here, so it will eventually become plus 2. So U square is 150 square, 2 into 5000 into S, okay? Got my point? So I can simplify here only 150 into 150 divided by 10,000. Got my point? This gone. It is 225 divided by 100, or I can simply write 2.25 meter. So this is that, this was the distance covered when the bullet penetrated into the wall. Okay. So this is like where you need, now remember, whenever you are going for the second chapter, make sure that you have studied the first chapter. because even in the second chapter, to solve the numericals, you will be requiring for the equations of motion, which we have discussed in the first part. Okay, so just go through that. And even if you have not studied, just remember the three equations of motion: v is equal to u plus at, s is equal to ut plus half at square, and v square is equal to u square plus 2as. Okay, these basic equations are very much required to solve these type of questions that comes under the force and laws of motion. Okay, so remember, now this was the displacement 2.25 meter. Also you can simply find out the force. Force is what? Mass into acceleration. Mass of the bullet is given 10 gram. You have the acceleration 5,000. So 5,000 into 10 is 50,000 Newton. I mean, you have to convert this 10 gram into kilogram. So what you do is 10 into 5,000, that is minus by 1,000. Okay. So this will get cancelled. Minus 50 Newton is the force exerted by the wooden block on the bullet. That is why it stopped eventually. Okay, got my point? So I hope these chapter force and laws of motion and motion are clear. Eventually your term 1 syllabus is over. Okay, just practice the questions from the NCERT and NCERT exemplar, and if you have any doubt, please let me know in the comment. Till then, bye bye, take care, enjoy.